Welcome into another episode of Everything is Logistics, a podcast for the thinkers in freight. I am your host, Blythe Brumleve, and we are proudly presented by SPI Logistics. And in this episode, this is episode 4 of our 5-part NASA series. And we are going to be talking about, obviously, we were at the Goes You mission that you probably heard that mentioned ad nauseum over the last 3 episodes if you've listened to any of those. But if you haven't, at the end of June or at the end of the month of June, I was invited along with a couple dozen other creators, photographers, meteorologists, to go to the Goes You mission to take part in a 2-day tour of the NASA facilities in Cape Canaveral, Florida. And because of that mission, so the mission was NASA and SpaceX, and then sending a NOAA satellite up into space. And NOAA stands for National Oceanic and Atmospheric Administration. It took me 4 episodes to finally get that acronym right off the top of my head. But in this episode, we are going to be talking about the next frontier. And the next frontier is space and building that infrastructure, really building it on here on Earth. So then that way we can build it up in space. And so for a lot of these missions, yes, they are, sort of one-time things. Like the Goes You satellite is a one every 8 years type of mission. But there are several companies all around the world and NASA in particular that are working on more and more missions from a private standpoint, from a commercial standpoint, from a government funded standpoint. So there are a lot of different moving parts that are going on in the world of NASA. And I think it's incredibly fascinating, both to partake in this tour, but then also the rabbit holes that it has led me down ever since then. So we're going to be talking about a couple different documentaries that are out right now that you can watch. We'll cover that in a little bit later on. The Wild Wild Space documentary that was just released on HBO was really, really great. And so definitely we'll mention that later on. But first things first is I want to talk about Lockheed Martin, because Lockheed Martin has been a partner of NASA for quite some time. And we were able to go to one of their buildings and be able to talk to them about the Artemis mission. And the Artemis mission is in addition to, all of the things that we were there at the tour to talk about from the Goes You, the weather satellite standpoint. But then also we were given a tour of different buildings around the NASA facility. And so one of those buildings was the Lockheed Martin building. And one of their spokespeople, which I will play a video from him in a minute, he was really like a great character to talk with. And it was a fun conversation. So I will play that video for you here shortly. But I did want to have some sort of level setting of what's going on with Lockheed Martin, with NASA. And so this will be a good setup in order to get into more of the manufacturing side of things and all of these different private companies that are starting to pop up. So level setters. Unlike other episodes in this series, you do not need to watch it on YouTube. I would still encourage you to watch it on YouTube because there are some fun visuals, but unlike the first 3 episodes where you really have to see it, sort of the stunning visual nature of how the large of a scale that some of these rockets are, these buildings are. I mean, it's incredible to witness the human engineering that is going on with these things. So you don't need to watch it, but there are a couple moments, one in particular with the Lockheed Martin representative that he passed around a heat shield panel that was from a working Orion spacecraft that was from that spacecraft. And it was a faulty piece. So they ended up having to replace all of it. But this was an actual piece from one of the Orion spacecraft. So he got to pass that around and see it and touch it and feel the weight of it, which there was no weight to it. Kind of looks like a piece of foam with foil around the outside of it. Obviously, it's much more complex than that, but that's the kind of thing that you would see if you watch the YouTube version. But you don't need to. So if you're listening on podcast, just keep listening, and you'll still hopefully will learn some new things. And then next level setter that I want to talk about is the new Artemis missions. So You probably heard of the Apollo program, where Artemis is the next Apollo. It's kind of like Apollo 2.0. Artemis is going to be the first effort or the first missions, especially led by NASA, since the Apollo missions, that we are going to be sending humans back to the moon with the goal of building a base on the moon. So then that way it can kind of be like a relay point between Earth and then the moon, almost like a layover if you think about it from a flight perspective. But we have some infrastructure to build on the moon first, and so we're going to be talking a little bit more about that later on. I had admittedly I didn't know too much about Artemis. I had heard that phrase before, and I knew it had something to do with NASA, but I didn't know that that was the goal of the mission, is to build a base on the moon, have humans, be there and building it out and staying there for long periods of time with the goal to be that relay point or be that layover point for folks who are going to be doing the same thing, but just on a different planet, which is crazy to even, speak those words. Next level setter is I was really surprised. I guess surprise is the right phrase to use. But my group that I was with is a couple dozen of us that were invited on this 2-day tour. It's called NASA Social, which is you kind of got to like apply to it. You got to stay up on their new email newsletters. If you're anything like me, you won't get accepted the first time or even the second time. It took me 3 tries to apply to this program in order to get accepted in. I will say that there was definitely a lot of meteorologists on the trip, just because, or on this tour, simply because of the nature of the mission. It was, for NOAA. It was for weather related, satellite weather predicting data capabilities, that kind of thing. There were also a lot of photographers, like astrophotographers, that were in my group as well. I don't think there were any other podcasters like me. Now that I think, I don't think there were. I think I might have been the only podcaster on the trip, which is kind of cool to think about. But I was there to cover the logistics part of this. So this is obviously, going to be really like manufacturing and supply chain heavy, versus like the growing food in space episode, which is a very important component of setting up infrastructure, is being able to feed your workers. So that's why that episode, I think it was episode 2. And so I'll link to all of them in the show notes. So if you missed any of them, I highly encourage you to go watch them, go listen to them. There's deep space logistics, there's how to grow food in space. Then there's a really in-depth coverage of the NOAA satellite and how, obviously weather affects everyone, but how the weather data collection works. And then basically it's just a bunch of really smart people that are trying to make predictions off of that data that everyone essentially has access to. So just a couple different level setters. One more level setter in the group is that, or within the group that I was referencing, is how many of them were space nerds. So it was really kind of cool to hear people spout off, sort of space facts of which astronauts were on what mission, and what year, and the goal of that mission, and the good things that came out of it, the bad things that came out of it. Like this is going to sound dumb, but there are people who know those kinds of like astronaut space facts that, like, for me, like football knowledge, they could spout off these different stats. Like I could spout off, Jacksonville Jaguar stats. And that was a little like, I don't want to say jarring to me, but it was surprising to me that there were fans like that out there. But it makes total sense now, especially considering just the impact and sort of the aura of these folks. Their passion, like I thought I was passionate about space. I nowhere near the level of passion, the level of enthusiasm and fandom that they have, not only for NASA, but for SpaceX and for, some of these other satellite and rocket companies. So we're going to talk a little bit more about those other rocket companies later on in the show. Are you in freight sales with a book of business looking for a new home? Or perhaps you're a freight agent in need of a better partnership? These are the kinds of conversations we're exploring in our podcast interview series called The Freight Agent Trenches, sponsored by SPI Logistics. Now, I can tell you all day that SPI is one of the most successful logistics firms in North America who helps their agents with back office operations such as admin, finance, IT, and sales, but I would much rather you hear it directly from SPI's freight agents themselves. And what better way to do that than by listening to the experienced freight agents tell their stories behind the how and the why they joined SPI. Hit the freight agent link in our show notes to listen to these conversations, or if you're ready to make the jump, visit spi3pl.com. But for this speaker that I'm going to play a video from, it's about a 20-minute long, I guess, clip, quote unquote clip. But he's standing in front of a quarter scale model and the Orion spacecraft. And he mentions that the spacecraft was a team effort, one part manufactured by Lockheed Martin and the other part by the European Space Agency. And so kind of like a lot of, I guess, European electronics and American electronics. Most people who have traveled over to Europe know you need to bring that converter plug over when you travel because we don't all have the same working plugs. Well, that's the same thing that's going on with the European Space Agency and the American company in Lockheed Martin. So I thought that was interesting that the Orion spacecraft that he's standing in front of, he mentions what part was built by the European Space Agency, what part was built by Lockheed Martin, and then Lockheed Martin had to go in and make almost like an adapter to make the two functions fit. And I thought that was such a good analogy to really display the way the private sector and the commercial sector are helping these other space agencies really take that next step where funding and budget have been such a big obstacle to overcome. I think there was one clip from our Deep Space Logistics episode where they said that NASA used to have 4% of the budget and back in like the 50s and the 60s. And that's when we first went to the moon. And since I think the 80s, the budget has been cut dramatically. So it's like 0.25% of overall GDP is what NASA's budget has. And a lot of the people at NASA believe that they would have already been back on the moon, that they would have been building already towards future Mars missions or could already be on Mars if NASA's budget was the same as it was back in the 60s and the 70s. And so I thought that was really eye-opening that these space agencies almost need the private sector and the commercial sector in order to further space exploration, experiments, things like that, that benefit us all. One of the better quotes that I've heard is that money that's spent on space stays right here on Earth. And so this is a massive investment being made by lots of companies. And so for, just to kind of, I guess, kick this episode off, we're going to play that speech from the Lockheed Martin speaker, and then we'll come back with some takeaways and then get into the second part of the episode, or of this episode, where we talk more about, what other private companies and commercial companies are stepping in order to help build that next frontier. So let's go ahead and play that clip.
Orion for the at NASA Artemis program. There we go. Am I social media correctly? I only have Twitter. I actually see quite a few familiar faces already in the crowd. Good to see you guys. Also, I support local artists and things. These are my Harper shoes, Harper's Cheyenne shoes. I work on the heat shield for the Orion program, and I brought some thermal protection system, one goodie with me. The reason I was starting to run late was I was trying to ask what questions of what can I bring for show and tell and what can't I? I got down to one. So, I'm a production planner on the thermal protection system, which is the heat shield for the Orion spacecraft. I know you all are here for the GOES launch, of course built by Lockheed Martin on top of the Falcon Heavy, built by SpaceX. And looking around the crowd, I already know you guys are pretty familiar with the NASA Artemis program, but let's start with just the very basics. What you're looking at is the Orion spacecraft. The Orion spacecraft, we consider three different parts. You have the crew module built by Lockheed Martin. You have the service module built by the European Space Agency. And for anyone that's ever traveled abroad, if you connect something made in America to, have a plug for something made in America to a socket of something from Europe, you're going to need an adapter. So you have the crew module adapter right there in the middle that Lockheed Martin also built. So the 3 different segments connect together to make the short stack. So where are we right now with the Artemis program? We already launched 2 Orions into space already. Exploration Flight Test 1 launched in 2014, and I'm sure you all are familiar with the Artemis 1 launch that took place at the end of 2022. And we are now working on Artemis 2, 3, and 4, all inside of this building right now. So Artemis 2 is actually getting ready to go inside the vacuum chamber by the end of the week. And then it will get vacuum testing complete. Then it will do its final integration and testing and will be what we call DD-250, which is basically the official paper that you sign that says it is no longer Lockheed Martin's possession, it is now in NASA's possession. So that will be happening next year, early next year. And then it goes from this building out the door and back to the MPPF, Multi-Payload Processing Facility. I'm going to try not to acromania everybody. Multi-Payload Processing Facility, where you put the fuel inside of it, which is hydrazine, the really nasty stuff that is certified only inside that building, but not this building. And that will give it all of the thrusters the ability to control its descent upon reentry. After it is done at the Multi-Payload Processing Facility, it goes to the Launch Abort System Facility, which if you go out and you look over this building, you're going to see a really tall building behind it, and that is where we install the Launch Abort System on top of the short stack. After the Launch Abort System is installed, it goes down the road to the Vehicle Assembly Building, where it will meet the SLS rocket and be stacked on top. So we are very close for completing all those major milestones. We're getting the Artemis 2 crew module ready for DD-250. Meanwhile, in New Orleans, I know that there's a NASA media event coming up soon, I think like next month, because they are just about to ship the SLS core stage from the Michoud Assembly Facility in New Orleans here to the Kennedy Space Center. And everyone here is space nerds just like you all, so last time Artemis 1 came in, we all go outside and we watch the Pegasus barge come in and we cheer on the SLS rocket coming in the door. So I'm really excited about that. We do that for every launch, by the way. We watch every launch. This is a really cool place to work if anyone ever has any career aspirations to be in the space agency or a space program at all, because we all go outside, watch every single launch. It doesn't matter who's launching. Space is space. It's fun. So if none of you all have seen a launch before, maybe if this is your first Falcon Heavy, you're in for a treat. Okay, so that was Artemis 2. Artemis 2's goal is to go around the moon, just like Artemis 1 did. But the difference between Artemis 1 and Artemis 2, I'm sure you guys know the difference. What's the difference between the 2 missions? People, astronauts. You all probably already know the names of the astronauts. We'll have Christina Koch, who will be the first woman to go around the moon. Victor Glover, who will be the first person of color to go around the moon. You have Jeremy Hansen, who will be the first non-American to go around the moon. He's a Canadian Space Agency astronaut. And then you have Reed Wiseman, who is the commander. And Reed Wiseman is not just an astronaut. He was the former head of the NASA astronaut office. So we don't just have like an astronaut as our commander. We have like the astronaut as our commander. So we're all very excited. This is a really great crew. They're going to go around the moon in the same orbit where we'll eventually put the Gateway space station in orbit around the moon. It's a much larger orbit around the moon than any of the Apollo missions have done previously. So that means all 4 astronauts will go further from Earth than any human has ever gone before. So you'll have all those milestones of all the people from different places that have ever been there before, and also all of them will go further than anyone has ever gone before. So exciting history is being made right here inside this building. It's fun to be a part of it. Meanwhile, we're working on the Artemis 3 crew module. Let's see, where is Artemis 3 crew module? It's currently in what we call clean room welding. So beyond those doors, if you look down that hallway, you'll see the room called the Industrial Operating Zone. That is where we build all the spacecraft, and that is a Class 10 clean room. But inside that Class 10 clean room is a smaller Class 7 clean room where you have to do propulsion, environmental control, life support system welding. So, sorry, that's a big mouthful. ECLIS and prop. That means that we have tubes, they have to close, and you don't want foreign object debris inside of those tubes for some very obvious reasons why you wouldn't want, the things that go, propulsion to have contaminant inside of it, as well as the oxygen stuff. You don't want contaminant inside the stuff that feeds the oxygen to your astronauts. That'd be a bad day too. So that's where that is. We will be finishing up with clean room by the end of this year, and the goal is to meet the next milestone after that called initial power on. So you leave the clean room, you install all the electronic stuff, all the stuff that is like dirty to install, wire harnesses, all the stuff that would possibly cause particulate contaminant. After you're done with the clean room, you can start installing all of that. Then you reach a milestone called the initial power on, which is where you feed electricity through the wire harnesses of the Orion spacecraft for the first time, and it becomes what we consider alive and like actually turn on. You can start doing functional testing to all the wire harnesses, all the electronics. So that's going to happen second quarter of next year. Artemis 3 service module will be coming here by the end of next year, or by the end of this year. So that's another exciting milestone. So you can kind of see that we have all these milestones, but it's not just two. We're actually really excited about a bunch of things that are coming up for Artemis 3. And we're also working on Artemis 4. We're in a stage right now called the secondary installation. What does that mean? So the pressure vessel comes in from the New Orleans Machines Assembly Facility, and it comes as a welded piece together box of, shape of aluminum that is in the basic shape. But then we have to install rigidity structure to it, and then it has to pass the proof test, which means we overinflate it on the inside to make sure that it can withstand the rigidity of space by having, a vacuum on the outside but oxygen on the inside. Just like a balloon, pressure pushes against the inner walls of the crew module. So instead of sticking it inside of a vacuum, we overinflate the inside with helium gas and basically get that same type of structural strain to make sure it's able to withstand that strain, also to validate all the welds that were done and validate that the structure that we installed is giving it the properties that we want before we continue moving on with the spacecraft. So Artemis 4 has already passed that milestone. We're now adding, that was primary structure, we're now adding secondary structure. Secondary structure is what holds the next major components, whether it be a tank or an assembly or electronics or wire harnesses. It basically creates all the bracketry that other components are then installed on. We will be going into the clean room soon for Artemis 4 once Artemis 3 has left the clean room as well. So that's where we are on Artemis 2, 3, and 4. I'm currently holding a thermal protection system tile. You're going to notice that when you see pictures of the Artemis 1 crew module, it's nice and shiny like this. That's because it has a little thin layer of this reflective tape, which has a couple of properties. It's called PSYOPS tape. It reflects the sun away, obviously, so that way the spacecraft doesn't get too warm, but it also has insulation properties, so that way when sun isn't touching the tile doesn't get too cold and brittle. So it both keeps it warm and cold at the same time, completely passively. The tiles were designed the same way, similar design as what the space shuttle had. You guys have been to any of the Kennedy Space Center Visitor Complex, been to Smithsonian? Have you seen a space shuttle, gone on any of it? What's on the other side of the space shuttle? It's all black, right? You have 10,000 of these as the underside of the space shuttle. So this was the main heat shield of the space shuttle. Space shuttle went into orbit and went 17,500 miles per hour. That's the speed you need to stay into orbit. That's the speed the Hubble goes. It's the speed that the International Space Station goes. So that's basically the speed that all shuttle missions went. Now to get to the moon, you have to reach escape velocity, which is 25,000 miles per hour. So the difference of hitting the atmosphere on reentry at 17,500 miles per hour versus 25,000 miles per hour is you get much, much hotter. In fact, you get a little over 1,000 degrees hotter. The Orion space shuttle, which takes more than the space shuttle. So that is twice the temperature of hot lava in Hawaii and half the temperature of the most outer layers of the sun. So that is what we were tasked to build. So a tile like this would melt. So we went back to the same type of technology, or at least material that they used in the Apollo, Gemini, and Mercury program, which was an ablative heat shield. So this is really lightweight. In fact, I will pass this around, let you guys look at it. This is a scrapped part from Exploration Flight Test 1, so it is a real part that was intended to be installed on the Exploration Flight Test 1 vehicle, but it was scrapped because the tile next to it needed to be redesigned, which meant that tile needed to be larger, which meant this tile needed to be smaller. It was already built, so we had to make both new tiles. Luckily, I get to now use it as my STEM education tile.
Thank you.
Anyway, so we use ablative heat shields now. It's a much thicker material, and it ablates away layer by layer. And obviously, it won't be reusable. These tiles were designed to be reusable, but a heat shield actually burns away upon reentry and is able to withstand that 4,000 degrees Fahrenheit temperature. Okay, before I just keep on going on and on, which I can, I probably should actually mention, we've talked about what Artemis 2 does. Artemis 3, that will be the mission currently planned to take the next people to walk on the moon. First man of color, first woman. And Artemis 4 will be the one that starts building the gateway, which will also include the new exploration upper stage of the SLS Block 1B. So a much larger upper stage that's able to carry significantly more cargo and will enable us to start building a space station around the moon. And that space station called the Gateway has its own propulsion and power element, which means it can change its own orbit. So you can have equator missions just like every single Apollo mission. Every single Apollo mission was on the equator of the moon. The goal of the Artemis program is we want to go to the poles of the moon because Shackleton Crater is so deep the sun doesn't touch the bottom of it, which means we believe that there could be solid ice resting on the surface of the moon. If you have solid ice, that means you can go get it, you can melt it, you can drink it, you can split it into hydrogen and oxygen. Oxygen obviously is something that the astronauts can breathe. Hydrogen is what the future human landing systems are supposed to be using for their descent, which means you can now make a gas station on the moon. So the ability to find water on the moon is a major goal of the Artemis program, and we're hoping that if we can get to Shackleton Crater, it will be hopefully easy to find it. Otherwise, you have to start figuring out how to get water in other ways. Okay, I'll stop there. Questions? Yes?
So I'm imagining that's a scale model behind you. Like, is the full-size one? Would it, like,
This is a 1/4 scale. Thank you, son. I was like, I know it's here somewhere. Yeah, quarter scale model. From what I can tell, it's pretty accurate. Oh, another cool thing that we're building right now here, docking module. Artemis 1 and 2 did not have a docking module. Artemis 3 is going to need one because we'll be docking with the Starship. Starship will be our human landing system. The docking module is currently in work, and of course, it's the first time we've ever built one. Yes?
So, in pictures from the Artemis 1 mission, the skin of the module was like bluish, but here it's like silver. So,
Yeah, so it was silver, and that tile that passed around, it is exactly that material that you saw. And what you're seeing, I think, is kind of like a reflection, kind of a photography effect. It is definitely was the same silver material, color.
gotcha. Cool. Okay.
How are you planning like cargo shipments? Are you sending all of the astronauts up with everything that they would need, or are you scheduling regular cargo shipments to them?
Yeah, and I might call Madison in to help answer that one with me. Okay, very good. So cargo, there's going to be a wide variety of missions. Artemis 3 will take everything it needs with it. Future missions after that, we start building a gateway. It'll be very similar to resupply of the space station, and you'll have the CLIPS contracts, and other will be inviting commercial NASA. I'm Lockheed Martin. I'm going to don't want to speak for NASA, but the plan will be to invite commercial contractors as well as international partners to help be a part of assembling the gateway as well as resupplying. Is that the correct answer?
Yeah, and like Barry mentioned, you can think of it as our International Space Station resupply missions that go up every few months. One of our next stops, we're going to talk to our folks who are called Deep Space Logistics. And so part of their role is kind of that logistics module on the gateway and how we're going to get, our stuff to and from that gateway.
Awesome.
So you really did answer.
I'm glad to have a fact checker. By the way, I'm happy to have Jared here with me because it's fun when I mention I'm on Twitter every so often, and there's been like a couple of occasions where I tweeted something and then either Jared or Gary Napier has texted me within 5 minutes saying, hey, just so you know, delete that. They watch my social media very closely. Yes.
I heard in the news that there was a problem with the heat shield.
Sure.
On the first Orion, the first Artemis one.
Yep.
Has that been worked out yet? And are they making those?
I see Jared laughing, and you're going to have to... So since I work on the thermal protection system, I'm a little bit too close to answer some of that type of questions because I got to remind myself what's public and what isn't yet. But the answer is yes, absolutely. Whenever you have a scientific mission, things don't happen exactly the way you expect it to. And if things don't go exactly the way you expect, you then have to do a bunch of engineering and test analysis and decide, what is different than what our models said it would be, and then what is our corrective action. So I was actually in a FRB, a review board, last night until about 7:30 p.m. with that discussion. And yeah, absolutely, they have tested and tested and tested, and have actually been able to replicate some of what you've been reading about, and they are working on that right now. Let me put it this way. I'm personally not concerned about it, but you have to go through the process of this is what we expected, this is what happened. Here are the deltas, here's why it happened, and obviously we're flying crew on the next one, and we are all extremely concerned about the safety of our crew. And here at the Kennedy Space Center, we have the Apollo Challenger Columbia. Oh shoot, what is the program called? Anyway, it's a program that kind of goes through, teaches all of us about the safety culture and what went wrong and why were those things not caught ahead of time. And one of the big things that came out of that program for me was that you should always be asking the question on, let's say there's something, a delta. Prove to me, I'm going to make the assumption that the crew module is not safe. Prove to me that it is safe. As opposed to, I believe our crew module is safe. Prove to me that it isn't. Depending on how you go about the culture of testing might depend on what your final answer would be. So we very much are concerned about the crew and are going about it with the proper mindset.
Good answer.
Thank you, sir. What's that? Yeah, absolutely. The crew's lives are the most important thing. And you know, they're test pilots. A lot of them are test pilots. And test pilots are in a risky business. They've always been in a risky business. Astronauts have always known that they are in a risky business. But the difference between losing a test pilot in the Air Force and losing an astronaut is a national tragedy. So we're all very well aware of, you know, we lose our mission, we lose our crew. It's the entire nation will stop. The program will stop. Everything will stop. So we got to do everything we can to make sure that we are able to keep going and our crew is safe. Although we don't want to end it on that. That's a question on that.
How much larger is the Orion craft versus the command module from that whole mission?
About 30% larger, 33% larger. And there's a lot more creature comforts on the inside, especially if you guys want to go YouTube some fun things. Go look at, oh man, I'm trying to think. Vintage Space is one of my favorite YouTube accounts. There's others. But I'm not going to explain how astronauts went to the bathroom in the Apollo program, but it's a fun YouTube if you haven't heard that one yet. We have a toilet, just like the International Space Station has. And the toilets were started back in Skylab, and then the first space shuttle had one. And now we've got that technology figured out on Space Station, and Orion will have one as well. Apollo spacecraft didn't have one. It is designed to withstand up to 1,000 days in space, depending on how large your service module is. Obviously, this service module, it would have to be a different design of service module, but the crew module itself is designed for longer duration missions, for anywhere within the inner solar system, meaning you could have an Orion spacecraft, depending on how you configured some other mission aspect things. You could go to Venus, you could go to Mars, you could do the asteroid belts with changing the design a little bit. So that means you have to withstand much longer durations, stays on it, which means the radiation of the spacecraft itself has to be hardened, which we've proven. The thermal protection system has to be significantly hardened compared to Apollo spacecraft, which we've proven. The technology on computers, as you can imagine, has changed a little bit just by looking at what your car looks like on the inside today compared to what it might have looked like back in 1960. By the way, there's some really cool pictures on the walls of this building being built in 1963. And I love looking at that picture because of the parking lot. There's like cars out there with giant tail fins. So if you can imagine what your car would have looked like on the inside and outside in 1963 versus what your cars look like today, you can imagine the difference between a spacecraft built, designed in 1963, 1970 versus today. The inside is significantly hardened for new technologies. In fact, when we were going to the moon, radiation technology was still just kind of being discovered. A lot of these technologies were just kind of being discovered. We have now had the benefit of the entire space shuttle program to throw that type of technology into this thing. The last thing I want to say is that we have an exercise machine, a rowing machine, inside of this vehicle. So that's something that they didn't have back in the Apollo program. And also, I talked about the toilet. It also has a little privacy curtain, by the way. They didn't have that in the Apollo program either, so they were all in there, and it's just like...
You'll turn like this.
Yeah.
Artemis 2 and 3 back there?
And 4.
4.
Yes.
So we get to go in each one of them?
Get to go inside?
Yeah.
I don't get to go inside though, so no. That requires an 8-hour training called confined space training, and some of them are actually clean room environments right now. So after passing the clean room, you actually have to full dress up in a bunny suit just to go inside. The astronauts were in here last month, and they got to go inside Artemis 2 for the first time. So, yeah, the astronauts just now got to go in for the first time. My hope for going in is kind of low.
Brokering success demands a battle-ready strategy. TIE TMS equips freight brokers with the ultimate battle station for conquering a tough market. With TIE, brokers gain access to a comprehensive platform where rate intelligence and quote history converge on a single screen. It's not just a page, it's a strategic command center designed to help brokers win. TIE equips your team with all of the data they need to negotiate with confidence and allows them to communicate directly with carriers and customers from a simple control base. Revolutionize the way your brokers perform by giving them a competitive advantage with TIE TMS. For more info, go to tai-software.com/battle stations, and we also have a link for you in the show notes to sign up for a demo. All right, I hope y'all enjoyed that clip. And as promised, let's talk about a few of the takeaways from it. Now, first, I want to show y'all the manufacturing process by Lockheed Martin for this satellite, the GOES-U satellite, because they really, and I mentioned this in another episode, but the whole sort of like space ecosystem, like NASA's team, Lockheed Martin's team, like all of SpaceX, of course, like all of these teams do a really good job at documenting their entire process and then sharing it with the world via social media. So Lockheed Martin and the GOES-U team, they have all of these manufacturing pictures of the making the satellite itself. And I don't know if I explained this properly before, but the manufacturing process is obviously an intensive one. But then you think about the process of shipping that satellite from where it was being built was in Colorado all the way to Cape Canaveral in Florida. Any kind of like jarring, any kind of like accident or turbulence can all affect like the smallest instrument on this satellite. And it's so intricate that I want to bring up I guess the documentation process of what happened during the manufacturing process of this satellite. They have a Flickr account, which I had not heard the name Flickr in a very long time. It's a photo sharing site for folks who are curious or maybe you're a little young to remember the photo sharing site Flickr. But NOAA Satellite still uploads tons of photos and imagery to this to their site, and so they documented the entire process. I mean, look at some of these images. I mean, if you're just listening, it's a giant room with a lot of different electronics and space equipment, and it looks like there's all these like solar panels that actually go on the satellite itself, and lots of people in sort of full protection, sort of to protect more of like the equipment, I don't know, nail clippings or hair or follicles, anything like that from getting into some of these really, really small instruments. I mean, you don't want any of that, impacting at any point where, a small, like, piece of hair that fell onto an instrument could probably have a lot of effect on the data that it's going to be capturing and that it's going to be reporting. But I just thought this was so cool that they showed the entire process of building the satellite and then testing it, and just the whole manufacturing process of it. And then eventually they wrap her all up and they put it into a capsule and they test that too. And then they take the entire thing and they put it into a special container that is made specifically for the satellite. And that's the container that they then ship over to Cape Canaveral in order to, I guess, begin the next part of of the shipment process or of the logistics process. The next thing I want to share is I know if you were paying attention to the conversation by the Lockheed Martin spokesperson, then you would have heard him say the NASA barge Pegasus. So the Pegasus barge is referred to quite frequently. Ever since I heard this phrase, the Pegasus barge, it made perfect sense because I had heard that phrase, and maybe this is kind of like the Artemis phrasing too, that I had heard that name for quite a long time, very similar to the Pegasus barge, but I didn't really know, any other details outside of just hearing about it. So if you're looking on the screen right now, you can see Barge Pegasus that's docked in the harbor at a facility in New Orleans. And so New Orleans, actually, very surprisingly, they do a lot of NASA shipments as well. So typically what will happen is, like, say for this example, NASA, or not NASA, but Lockheed Martin will take that satellite, ship it to New Orleans via air, and then from New Orleans over to the Cape Canaveral, then they will put it on a barge. And so the barge will go really, really slow. It will avoid, obviously, inclement weather. But it's not like a typical barge where you just kind of throw whatever on top of it. Like, it is very intricate. If you're looking on the screen, you can kind of see it. It looks like obviously it looks like a barge, but then it has a big white shield kind of built around it to contain whatever they put inside of it. So this Pegasus barge has been used for a lot of different shipments. For the stat nerds out there, it's about 310 feet long, 50 feet wide. Cargo deck length is 240 feet. The width for cargo is 36 feet. Usable cargo deck height is 41 feet. Onboard power, there's also tugboats, engines. None tugboats or towing vessels are required to move the barge. It says NASA has for decades used barges to move its large spaceflight structures. Pegasus was specifically designed and built in 1999 to transport the giant external tanks of the space shuttles from the Louisiana shore to NASA's Kennedy Space Center on the eastern coast of Florida, a 900-mile journey that includes both inland and open ocean waterways. Pegasus replaced Poseidon and Orion, barges that were used to carry Saturn rocket stages and hardware for the Apollo program. Pegasus completed its final space shuttle related voyage in 2011. I don't know if there's really, if you're looking at the screen, you can kind of see a lot more of the photos that sort of definitely show the scale of it. I'll link to this in the show notes in case you want to check that out. But I just thought it was interesting that that the speaker mentioned that they're going to throw it on a barge, or that everybody within the office goes out and watches all of the barge shipments come in. Very similar to the rocket launches as well, where I personally witnessed that, where during the launch itself of the GOES-U satellite, everyone that was working in all of the buildings around the facility that we were at were outside, all of them watching the launch. And so it's kind of cool to know that all of the people that are working there are also fans. Why wouldn't they be fans of the work that they're doing? And so that was really cool to hear, is that even when, there's no cameras around, or it's not like a big flashy launch, that there's still people, there's still rockets coming in on a barge, and everybody runs outside to go watch it come in. I thought that was a cool moment from the speech. Then you can also, if you watch the video, then you saw that he passed around the sheet of the panel, aka the piece of thermal protection system that helps protect against heat and radiation, which was, I said before, that was surprisingly light. It felt like a regular piece of foam with just some aluminum foil around the outside. Obviously much more expensive than that. But one cool note is how they also believe that there's solid ice on the moon inside of Shackleton's crater. If that's true, the major mission of Artemis is going to be finding that water at the bottom of Shackleton's crater, and then being able to use that for, you can imagine, finding water on the moon, or finding ice that can be turned into water is something really, really major, and would help out from, for future missions, because water is essential for, obviously, humans, and then also for making plants grow in space. If you listen to our How to Grow Food episode, that could be a vital component in order to help expedite some of those efforts on growing food in space. And I also love the fact that they call it Shackleton's Crater, because I'm reading this book called Endurance, and it is about Shackleton. He led his group of, I think it was 28 men off the coast of South America, and they wanted to be the first group that landed in Antarctica and then traversed on foot to the South Pole. It's they face a lot of challenges. They face an incredible story of leadership, of humanity's desire to sort of explore and to push forward. I won't spoil it for you, but very much it's called as one of the great adventure stories of our time. But the book is called Endurance. It's by Alfred Lansing, but it's basically I'll read a first couple paragraphs on the back of it. It says, in August 1914, polar explorer Ernest Shackleton boarded the Endurance and set sail for Antarctica, where he planned to cross the last uncharted continent on foot. In January 1915, after battling its way through 1,000 miles of pack ice and only a day's sail short of its destination, the Endurance became locked in an island of ice. Thus began the legendary ordeal of Shackleton and his crew of 27 men, not 28. I think I was counting Shackleton in that number. For 10 months, the ice-moored Endurance drifted northwest before it finally was crushed between two ice floes. With no options left, Shackleton and his skeleton crew attempted a near impossible journey over 850 miles of the South Atlantic's heaviest seas to the closest outpost of civilization. Their survival and the survival of men they left behind depended on their small lifeboat successfully finding the island of South Georgia, a tiny dot of land in a vast and hostile ocean. In Endurance, the definitive account of Ernest Shackleton's fateful trip, Alfred Lansing brilliantly narrates the harrowing and miraculous voyage that has defined heroism for the modern age. It's incredible. I've only gotten about halfway through the book, and it's very, very good. So if you've never read this book, definitely go out and read it. And if you have read it, then you understand the significance of what that crater on the moon, calling it Shackleton's Crater, and having ice at the bottom of that crater in order to so hope, that could lead to a lot of cool things for the Artemis mission. Just really, really cool to learn that little note. I had no idea that it was called Shackleton's Crater, and that was the whole goal, or is the whole goal of the Artemis mission, is to be able to build a base around there so that they can tap into that frozen water that they believe is on the moon at the bottom of that crater, and then use that as a relay point to Mars. Just super cool. Okay, but now that we kind of know about how a company like Lockheed works with NASA and their role within building the base on the moon, you probably might ask yourself, well, why hasn't this been done yet? And well, in our deep space logistics video, I kind of already touched on this before, but he mentioned about the budget. And Matt Whitall from that deep space logistics video, he talks about how NASA gets what they get now versus what they got in the past. And I'm gonna read a quote that he said, and you can go listen to that episode to hear it in sort of full context. But for the sake of this show, Matt says, "Ask Congress if we have a continuing budget, then we can get it done pretty quick." Talking about getting back to the moon, getting to Mars. The biggest challenge to NASA, quoting Matt here, the biggest challenge to NASA is every 4 years our priorities change. If we were back up to the Apollo budget, which was 4% of GDP, by comparison, we are 0.5% of the budget. If we get back up to that 4%, we would have already been on the moon. Again, we would have a base, and I think we would be thinking about Mars. So it stayed about 0.5% of the national budget for a long time. And during that very small percentage, we've got the ISS, we have SLS, which is not the best rocket in the world, but if you compare it, against Elon's Starship, but with that 0.5% of GDP, 1/30th of what the Department of Defense gets, Matt says we still manage to do that. We're still trying to do it. And I have to imagine it has to be very challenging that every 4 years, every time a new president is in office, that your budget, your programs that you have been working on for years and years, maybe decades, could be at risk because of just the change of political parties. And so Matt goes on to say that they really need to be insulated from that in order to further their space goals and their space missions. As you can imagine, I'm sure working with the government is a lot of red tape. It's a lot of slowness to it, especially with the U.S. government, where there's so many sort of there's a lot of leaders and not enough, I guess, doers, if that makes sense. There's a lot of people that are spouting off of what should be done, but there are very few people that are actually doing the job that needs to be done in order to further a lot of these efforts. So that's a lot of sort of red tape from the NASA perspective. But where there's not, surprisingly, not a lot of red tape is in space. That has been one of the bigger, I guess, sort of eye-opening things, is that there are no laws governing space. There's no red tape in space. Basically, if you can hitch a ride and get into space, anybody can do it right now. So a few things that are happening around this movement and around the private sector and the commercialization of space, and that is what they see as. And when I say they, I'm meaning a lot of entrepreneurs, a lot of just space enthusiasts in general are starting up different space companies. They're getting VC funding in order to further their mission. So you could say that there's definitely a lot of space fans in the, I guess, the investment market, the private equity markets, and they're investing in a lot of different startups in it. So it's not just a SpaceX game anymore. What has really shifted this mindset is the rapid reusability of rockets. So for a long time, NASA, it was, use one rocket and it's done. You can never use it again. It's also very expensive. But if you can, with what Elon has proved and the SpaceX program has proved, is that if you can reuse the rocket, then you can make it dramatically much affordable. You can dramatically lower the price of the cost of shipping goods into space, sending humans into space, and furthering those, build a base on the moon, get humans to Mars. So there's a lot of that going on. So rapid reusability has been essentially a game changer in that regard. One of the quotes that I really liked from the tour is that you wouldn't throw away a boat or a truck after one use. So we shouldn't do that with rockets. Like, imagine driving a car once, on a road trip and then throwing it away. Like, that's essentially what, a lot of different space programs all around the world were doing from the 60s up until about, I think, 2008 is when SpaceX first launched. But launched as a company, I believe. They might have gone into space during that time frame. I think I have it in my notes below. But there were a few other pieces of content that I have watched since going on this tour, and one of them is a podcast that I listened to, the Acquired podcast, where Ben Gilbert, he's the host of the podcast, interviews Austin Link. Austin Link is the co-founder and CEO of Starfish Space. It's basically private companies that are helping to make it easier to commercialize space. A quote from the podcast says, if you want to get into space, you go on SpaceX because they have regular shuttle launches and it's affordable. The Starfish Space Company, they have satellites that they're launching up into space. And he said basically how satellites are the size of dishwashers. They're being flown into space on what's called a transporter mission, where hundreds of these satellites can be on a single transporter mission. He bought the ticket online, used his satellite specs, and then compared it to buying an airline ticket. And the waiting list for these launches is so long because there are so many companies that want to launch a satellite. Months and months. I believe he said in that Acquired podcast interview at the time of recording, I believe that released in May of 2024. Because on the podcast itself, he said that it takes about 9-10 months of a waiting list in order to get on one of these transporter missions. And then he goes on to talk about how if you kind of prove yourself as far as like you're being able to reliably send your satellites up into space, and then you are a good customer, then basically you can secure your own rocket launch for and just take up the entire, so it's almost like LTL shipments going up into space, that eventually you can rise up to where you are the full truckload. So you are the full rocket load instead of an LTL shipment. That's currently what Starfish is doing. Now, if you're wondering what the heck does Starfish do, they are a satellite maintenance and servicing company, which is crazy if you think about. There's maintenance companies. There's so many satellites in space that now they need maintenance companies that can help make the shelf life of a satellite much longer because they can perform maintenance in space on that particular satellite. He said, Austin goes on to say his 9-person team can come up with a plan for maintenance propulsion rocket and get it into space. They were able to use some already developed infrastructure like space cameras to deploy their satellite faster, which I thought was really interesting, that there's sort of like open source technology among the space enthusiast group that they can, and how Starfish sort of expedited their trip to space is that they were manufacturing these satellites, but they use already publicly available machinery and stuff like that. So they were able to use the developed infrastructure like space cameras to deploy their satellite faster. The infrastructure and services are now becoming more common. He goes on to say how companies like Starfish invest all this time and money into a product that is dependent on a smooth launch, and the high or lull of these moments can impact years of work and additional investment. All of the NASA social folks were really tense all day on Tuesday of that mission, of the Goes You launch, that I could visibly see. But you have to, like, I will say not necessarily the NASA folks that were nervous and that were stressed. It was the people in the group that I was with. So the meteorologist and the astrophotographers, even myself, like during the 2-day tour, Monday night, Monday evening, it was the first day of the tour. And everybody was really stressed because we had no idea if the launch was actually going to take place. I'm a Floridian. I know that these storms roll through every single day. But the unique location of Cape Canaveral and the unique weather that happens on some of these barrier islands off the coast of Florida, it creates a unique weather area where you're almost insulated from those afternoon storms. I say this as somebody who, used to live 4 minutes from the beach. Now I live 28 minutes from the beach, and the weather reports are vastly different. It could be pouring down raining for my house here, and 30 minutes, a 30-minute drive, I can be in blue skies and sunshine. And so just knowing, I guess, the tense nature of the group, of our NASA social group, everybody was incredibly stressed. I remember having trouble sleeping that night because I wasn't sure if the launch was actually going to take place the next day. There were provisions or plans in place that, the group could stay an extra day and they would just push the mission back push the launch back from Tuesday into Wednesday. But the overwhelming majority of the people in my group flew in for this. They had plane tickets heading out of Florida on Wednesday. And so all of those people would have had to change their plans had the launch been delayed. It wasn't, I think it was delayed by like 10 minutes, which is fantastic. But everyone was so tense leading up to it. And this was only 2 days. I can't imagine what it's like to work on a project like this, or work on like a Starfish Space, for example, to work on a satellite for years or months and years at a time. And then your fate is, you're waiting around watching a countdown clock to see if it's actually going to take place. So the amount of stress that we felt over a 2-day period, I can't imagine what, some of these other folks, especially in the private sector, or even, not anyone who is around this kind of stuff. I imagine that the stress level has to be crazy, or maybe they're kind of just used to it. And maybe that's why, during a launch, it's almost like a relief that, the launch actually takes place, and, you can fly up into space and then get into orbit, and then the fun things can start, the fun things that you've been preparing for. But none of that stuff can happen unless you actually have liftoff. So thought that was a cool little note. because at one point, yeah, I forgot about this little. I'm just going through my notes here, but one of the other notes that I had is that on Tuesday the launch only had a 30% chance of happening, and so that's also what led to a lot of our different sort of stress levels. There were people within our group that were watching different sort of source accounts, rumor space accounts. In the middle of the night, they rolled out the rocket and attached it to the lift gate. I believe that's what it's called. So the rocket sort of sits upright and then it gets attached to the lift gate. And when the rocket is when the boosters are set, so all the flames are coming out at the bottom and it takes off, then the lift gate detaches from it to allow that flight up and over to take place. The Starfish founder, ending with a couple little quotes here. He said the bottlenecks are finding a spot on future launches, ordering parts that have a 12-month lead time. It's a long sales process, and the government not being able to keep up with the speed that startups are used to. So it's an interesting dynamic that you have sort of the red tape and political parties, leadership changes every 4 years, but then you also have the startup community that just wants to go 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 go, and they want to go fast. And what is that the famous line, like move fast and break things? That's the ethos of the startup community, and so it's interesting to see those two dynamics kind of butting heads a little bit. But the 12-month lead time, which is crazy, and then finding a spot on a future launch, and you can find that spot when you get accepted into that little layer. Then you can go in and you can purchase your plane ticket online, and yeah, that's crazy. I would say, last one that I thought was from Austin that I thought was really, really eye catching. He says that being the launch provider like SpaceX is coming as a huge commercial opportunity. It's the shovels to the gold rush. Because there's really no other, and this is a perfect segue into the next part and into the next piece of content that I really want to talk about, and that's the Wild Wild Space documentary that appeared on HBO. It just debuted, I believe, less than a month ago at the time of recording. This is August 16th. At the day that I am recording this is probably going to publish the last week of August, right before the Labor Day holiday. That's the goal anyways. But that documentary just released out on HBO. So if you have the Max app, then you can look that up. And it really is insightful to see some of these other people trying to become the shovels to the gold rush. One of my main takeaways from watching this episode is that I guess I could really go into a lot of details about this, and I think I might make this a future episode. But for the sake of this episode link, I want to do this episode justice without going into all of the details, because it really could be its own episode. So for a few of my favorite takeaways from the Wild Wild Space documentary is that one of the quotes, it says, "Whoever controls space may very well control the future of humanity. The fabric of our civilization runs on satellites." Think about it. Weather, GPS, obviously military, communications, all of these things are run by satellites. And from 2020 until 2023, there were 8,000 satellites in lower Earth orbit. We have managed to put up 2,500 satellites for decades before these years. Think about it. 2,500 satellites for decades before 2020, but from 2020 until 2023, there were 8,000. So it's almost tripled just in the last handful of years. That one of the people in the documentary, they say this is not going to stop. There's a good argument to be made that in 10 years we will be at 200,000 satellites, which means there's going to be a lot of satellites. I guess going back to the Starfish company, there's going to be a lot of satellites that are going to be needing some maintenance. The Wild Wild West also follows a few entrepreneurs from all different, I guess, walks of life. Very, very interesting people. A few of these entrepreneurs. So there's a few other different companies not named SpaceX. So there is Rocket Lab, there's Planet Lab, and then there's Astra. Astra is definitely the most controversial of the three that are featured in this documentary. And because the founder feels like everything that they warn you that Elon is. The founder is, he's okay. Kind of let me see. What's a good comparison? So, oh, I write this one down. Okay, yeah, I wrote this one down. Remember the movie I, Robot? Not Vicky, which is like the, artificial intelligence, like supercomputer device that Will Smith like, defeats in the end with, I guess, injecting Vicky with a virus, but the boss of the company, the boss of USR, which is United States Robotics, not real companies that exist right now, but in the I, Robot movie, the boss, so it's Bruce Greenwood, the character, he's the actor who plays the character Lawrence Robertson. That is what the Astra founder, it reminds me of, just kind of like this, I guess, ego driven capitalistic reasons. Like, that's the reason why you get the drift of like, he's really in it for the fame. And he's, they call him like a carbon copy of like a typical Silicon Valley entrepreneur, or still a typical Silicon Valley, founder. So if you think of it in that lens, then this Astra founder just makes much more sense. It's definitely like, is he a bad guy? Is he a good guy? I'm not exactly sure. So that was interesting. Astra, in case you don't know, their goal is to build smaller reusable rockets. They have faced a lot of funding issues. They were close to being delisted from the stock market because they had so many issues around different launches, a lot of failed launches. They also have one of the more famous sort of faulty launches that happened where the rocket goes a little sideways at launch. Obviously, it doesn't take off. It's not successful. But surprisingly, after all of those issues that Astra has been going through, they raised enough money again to go private. So earlier in 2024, the company Astra went private. Then the other company is Rocket Lab, and their founder is Peter Beck. And he almost feels like the mad scientist of the group. Apparently he was just like a space hobbyist living in New Zealand. He really, really wanted to go and work for NASA, but he said that when interviewing at NASA, it felt like everyone was talking about the things that NASA used to do, not the things that NASA was going to do. And so he really didn't want to work in that kind of environment. And so he founded his own company, Rocket Lab. Funny little caveat is that the Astra founder originally went and talked to Peter Beck at Rocket Lab, and with the under what Peter would, I'm assuming reading between the lines, what Peter believed was sort of like an intel mission, that the founder of Astra really only pretended like he wanted to work at Rocket Lab to gain intel, because very shortly after that he quote unquote interviewed over at Rocket Lab, that's when Astra, the company, was founded. And that's where, sort of these two competing companies who are trying to make reusable rockets, but they're trying to make them much smaller than the SpaceX rockets. And so then that way they're using less fuel, they're using less equipment. They're trying to make it, basically you have like the 2010 era, like H3 Hummer versus like the little, God, what is that little like scooter kind of car? It's kind of, you know which car I'm talking about. The very like small, like 2-seater car that I think it's in like it's famous like car chase in the Bourne Identity or one of the Bourne movies. Anyways, Mini Cooper. So yeah, it's like H3 versus a Mini Cooper. And that's how they're trying to, Astra and Rocket Lab are trying to make, kind of put their name out there by building smaller reusable rockets. Astra's had much more trouble. Rocket Lab, alternatively, has had a lot of success. I think to date, they have more than 50 successful launches, and they are now considered one of the top rivals to SpaceX. And they're starting to not just have their smaller rockets, but they're starting to build bigger rockets now to directly compete with SpaceX. So I thought that the Peter Beck seemed like somebody who was actually working on these things for the greater good. That was my impression anyways from this documentary. And so he seem like a, like almost like a Bill Nye, that's doing it for science. And I just kind of admire that. So that was really cool to watch. And then there's also this company called Planet Labs. That was another major feature in the Wild Wild Space documentary. They are an imaging satellite company. So they were the first primary, I guess, use case for their imagery satellite was to monitor deforestation. So Planet Lab, I guess, to sort of back it up for a second, they have, I think, anywhere from 200 to 300 imaging satellites all over the world. The idea is that you can make planet Earth searchable. And so they take a picture a day of the same spots all over the world. So then that way you can become that search engine. And so the goal initially was to monitor deforestation. But as you can imagine, an imaging satellite that's taking pictures all over the world, lots of people would probably find that information very useful. And so from my understanding, especially from watching the Wild Wild Space documentary, is that they are now more in their biggest customers, the governments. I say governments because it's not actually confirmed which governments they work for. Hopefully, they work for us for our own national security efforts. But there was an interesting. There were other interesting use cases that Planet has become the first company to take daily images of the Earth's surface. It helps farmers, unique weather events, wars, mining operations, oil use. And all of the data is open to everyone, which I think is very interesting. One of the examples that they gave, talking about Planet Labs' capabilities, is that when the U.S. went to war with Iraq, there were obviously those big claims of weapons of mass destruction. And the U.S. government sort of made the case for going to war with Iraq, that they had all of these different locations and facilities, and that they're moving, these equipment from this location to the next. And that was their proof. Turns out a lot of that proof was fraudulent. Years later, come to find out. There was a person in the documentary that said if these imaging satellites existed back then, that could easily be disproven from just a citizen scientist standpoint, or private companies that are, charged with looking at some of these images every single day. That would be a huge group of people that could now use those satellite images to prove or disprove claims like Iraq has weapons of mass destruction, which took very long time, a lot of money, and a lot of lives that were destroyed because of that unnecessary war. There was also a case more present day when Russia invaded Ukraine. Planet Lab could prove that Russia was bombing elementary schools and digging mass graves and things like that. Like, I think space is sort of seen as like such a positive thing. But there is a struggle as a startup to have the intention of starting up a satellite company to combat deforestation, and then all of a sudden, you're being asked by the government to provide images for countries that we are not on the best terms with. And so you can imagine all of the things that you would find out from daily imaging that these satellites are taking care of, or that are doing. A couple more notes here. The Astra founder and Rocket Lab founder absolutely hate each other. One is out of the business, and one is out for business, and I would argue that the other is out for the science. It's an interesting look at the sort of the competitiveness that has started to creep up among these different space startups, which leads me to this quote, that there is no one or country leading what should or shouldn't happen in space. No legal governing body is in space. And then they go on to sort of end the documentary by saying that all of these issues on Earth are going to follow us into space. It's just the way it is, which is terrifying, I think, in a way, especially if some of the worst people have access to, a lot of what they said in the next 10 years, 200,000 satellites are going to be up in space. nuts. Okay, so moving on to sort of the next couple segments as I sort of round out the show, that space launches are not just a handful of companies fighting for dominance and building the infrastructure in space. There are also real problems that require collaboration between these companies and governments, not just the US government, but governments all over the world, such as fuel remains a big problem to solve. I think that's kind of an obvious one, but that, it's an obvious problem that lots of people are trying to solve. A couple other things that I don't know that people are trying to solve just yet, but they probably should, is one of them is the mental health aspect. It isn't talked about enough when it comes to the aspect of sending humans into space and keeping them there for a long period of time. There was an example in Wild Wild Space that they talked about what happened in Antarctica. Basically, one guy, they had a bunch of books in Antarctica, a couple, citizen scientists or actual scientists that were down in Antarctica, was passing the time and reading a bunch of different books. And one of his colleagues would see the book that he was reading and he would just spoil the ending for him. And he did it several times, just being I don't want to say like being a jerk. And so when he was doing this thing, the guy who was reading the books got so pissed off that he just was fed up one day and ended up stabbing the guy that was spoiling all of the books. So it just kind of signals about the mental strength, the mental capabilities that are going to be needed for people that are living together for long periods of time in confined environments. And I mean, most of us have had an annoying roommate, or people we just can't stand. Now, imagine doing that in a place like space where you can't just get away. You can't just go take a walk around the block to, de-stress. So those are things that we really have to think about. And another aspect to this that they talk about during the documentary is how this lady who was a truck driver in South America, she started a religion that convinced folks that they are descendants of another species on another planet. And this signals to sort of the power of faith and how things like faith are the cornerstone of humanity. And so you have to have a plan for that when it comes to building space infrastructure. You have to have a plan for mental health. You have to have a plan for faith. Like, what does faith look like when you can travel to other planets? I don't know. I would love to hear somebody that has a tremendous amount of faith be able to comment on what they think about things like this and traveling to different planets, and how maybe their faith has evolved with this sort of expedition of humans trying to get further out into different planets and moons and set up bases and civilization. Like, what does faith look like in that regard? There's also making the argument about how important nature is to our soul. Like, how do we transport that? In the book that I mentioned earlier, Endurance, there's a moment in the book where the men, for the first time, I think in like 10 or 11 months, there was a stick, because you can imagine Antarctica is not a place where plants can live, but they were stuck on this ice floe, and the seaweed comes through and they find a stick from a tree, probably from South America, that they pull the stick out of the seaweed and they light it on fire. And the smell from lighting that stick on fire for these men was like a renewed sense of being connected to nature, knowing that things exist that are just not white and windy and cold. So I thought that if you think about Antarctica being one of the harshest place to live and to try to work, and all of these different things that Antarctica can be very applicable to the nature of space. And so how do we transport faith? How do we transport mental health? How do we transport our deep connection to nature whenever we are trying to become an interplanetary species? I just think that those are really interesting topics that I don't think are talked about enough in this regard. Kudos to the Wild Wild West, documentary for talking about it and for mentioning it, because it didn't connect for me until I read that line about the men being read that line from the Endurance book about the men being so tied to just their daily life of just being cold and on ice and seeing nothing but white all around you. And then all of a sudden, some seaweed floats by and someone lights a stick on fire, and it brings back all of these different emotions and makes you longing for home, being really homesick and longing for nature. So that's a really interesting parallel to what's going to happen to us as a species if we don't have these things that make us innately human, which is an interesting sort of, thought concept. But to close it out, I do want to end it with some other like sort of lighthearted and just because I think it's cool. A couple of little footnotes here as I've been diving into a lot of different resources and a lot of different information since the NASA social trip is their 3D printed rocket that was just created by India's space team. So that's another sort of evolution in the space process is all of these different countries that have their own space agency and what they're doing and the different initiatives that they're taking on. I think 3D printing is going to be absolutely crucial when it comes to solidifying space travel and building out space infrastructure. You're going to need to be able to build new things in space, and 3D printing is probably the best shot that we got at doing that. So I thought that was really cool that the India space team building a 3D rocket. There's also a company that was mentioned in the Wild Wild West or the Wild Wild Space documentary, and the company is called Leo Labs, and they track debris in space. Stuff as small as stuff as small as a screw can severely impact, a satellite in space. And so what they're doing, I think it was a few years, 2021 maybe, when Russia shot off a missile from Earth that took out one of their satellites. Satellite wasn't working anymore, but they shot off a missile to take out a satellite that wasn't working anymore, which obviously signals to space war efforts and communications and how that can be used as sort of a war strategy or a war tactic. But when they blew that satellite up, it created a debris field that was so massive. Like apparently the rest of the world, like all of these different space agencies, were furious that they did this because it created so much debris. And because these things are traveling so fast in space, something as small as a screw can deeply impact a satellite that's already up there in space. And so Leo Labs actually tracks debris in space, which I thought was really, really cool. So shout out to them. Maybe I can try to get them on a future show because that's so, I mean, when you talk about like visibility here on Earth, when it comes to logistics, like we track weather, we track traffic accidents, any of those other delays that could impact, getting the job done. Now, there are other companies like a Starfish that is doing maintenance of satellites in space. And then Leo Labs is also tracking space debris. These are all companies that you're going to need if you are sending satellites up into space, if you are building rockets and all of these different things. And then lastly, I want to end on a positive note. And you might wonder, okay, with all of these shipments going on in space, like what does it actually look like to get a shipment in space? And luckily for you, I have an image that I want to show. And this comes from astronaut Matthew Dominic. He is actually in space on the ISS. And this photo is just incredible. This is actually him getting a shipment. And in a tweet, he says, we received a cargo shipment this week with lots of cool stuff to include some new camera lenses. Spent a good part of the weekend with a 15 millimeter T1.8 lens. Don't know what that means. But he made a whole bunch of time lapses, still looking through thousands of frames, lots of which I have the aurora, but the Milky Way and this one stood out. So if you were looking at this image, it is absolutely incredible. I will link to it in the show notes, but that's what it looks like to get a cargo transport or a cargo shipment out in space. So this astronaut took this photo himself. He's been an astronaut he's been in the NASA space program since I believe 2017. But if you look right here and where my mouse is, that is the actual capsule that is bringing all of the shipments in, and it kind of docks here. And that's when, once it docks, then you can go and take out whatever stuff you need. Here's another image here that it just shows it from the astronaut. What did he call this? This orientation looks more natural, but the original post is how we see it on station. So Matthew Dominic is a fantastic photographer. He's taking these photos in space and tweeting them out on X. So I thought that was a good note to end on. So hopefully you enjoyed episode 4 of our series. If you want, go check out the other episodes. Like I said, Deep Space Logistics was the first one. Then we had How to Grow Food in Space. Then we had the NOAA episode. So this is our 4th episode. We're going to have one more, which is more of like behind the scenes of like the stuff that wasn't really a lot of meat on it to make it its own episode, but it's kind of a more fun, more lighthearted one. So I will make sure to link to all of those in the show notes. But thank you for tuning in, and I hope you enjoyed it.